Okay, Mr. Lear has drawn this probability tree diagram for this situation. 30 students, 16 boys, 14 girls, and 2 students chosen at random. Okay, we have to find one thing wrong with it. So, if 2 students are chosen at random, okay, that's the same as picking one student, waiting a couple of seconds, and then picking a second student. Okay? So it's important to realise that just grabbing 2 students at random is exactly the same as grabbing one and then grabbing another. Okay, so it's okay to write it out like this. The first student chosen is this one, and then the second student chosen is this one. Okay, 2 stages, even though they're grabbed at the same time. Okay, good. So the structure is fine, but the numbers are wrong. Okay. It's probability without replacement. That's essentially why the numbers are wrong. Okay? This is probability without replacement. Okay? Because you're choosing one student and you're not putting them back, and then you're grabbing another student. Okay? Again, even though you're grabbing 2 students at the same time, like I said, it's the same as grabbing one and then grabbing the other and not putting that first one back. Very important to realise that, which means it's probability without replacement. And so, to look at this mathematically, we can treat it as if that first student that was grabbed, or picked or whatever, is not put back. Okay, so let's correct it in red in time-honoured tradition. So, probability without replacement. What's the probability of choosing a boy with the first pick? It is 16 out of 30, that's correct. Okay, because to start with, there are 30 students in total and 16 of them are boys. What's the probability of choosing a girl? It's 14 out of 30, that's correct. Okay? But it's probability without replacement. So for the second pick, one of those students is gone. There are now 29 students. That's the whole point. So that should be 29. Okay? That should be 29. 29. 29. Okay? So that's now correct. You've already chosen a boy, so you're down to 15 and you're down to 1 student in total, so it's 29. 15 out of 29 is correct. Now it's correct. Okay. There are still 14 girls, that's correct. Chose a girl the first one, so there's still 16 boys, that's correct. You chose a girl the first one, so you're down to 13 girls, that is now correct. Okay, so that's what's wrong with it. Should be 29, not 30. And in your exam, mention probability without replacement. It will impress the examiner and get him on your side, and that is a very good thing. Okay. Right, next one. Mr. Slater. Okay. So, there's a football game. The probability that Owen scores in this game is 0.4. The probability that Wazim scores is 0.25. And Mr. Slater claims that the probability that both boys score in the same game is 0.4 plus 0.25. Is he right? Is he wrong? And why? Well, he's wrong as well. Because these 2 events, okay, the probability for that one to happen and this one to happen, and that's what we've got here, the probability that both boys score in the same game. So it means the probability of that happening and that happening. When you have the probability of something happening and something else, you multiply those 2 probabilities. Okay? You don't add. So that's wrong. Okay? We can make it correct if he had said the probability that both boys score is 0.4 times 0.25, that would be correct. Okay? that is now right. Because I'll go over that again. When you have the probability of one event happening, okay, and the probability of another event happening, the probability of that happening and that happening, you don't add the probabilities, you multiply. So it's actually 0.1. There's only a 10% chance of them both scoring in the same game. So Mr. Lear and Mr. Slater are both wrong. Maybe they ought to consider a change of career. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drgem.com, and I'm also on social media. Thank you.